This time we're going to take a look at strings, their indexing, their slicing, and comparison. Now a string is simply a sequence of characters. It's a collection of characters and it has an order. Because of that, there's also an index that indicates where a character is in a string. So let's take a look at a particular string. We'll grab Merrimack, which is a river near where I grew up, and that's a collection of characters. It is delimited by quotes. In this case I use single quotes, but you could use double quotes. You just can't mix them. And because it's ordered, each character has an index of where it is. Now what's strange, and something you'll have to get used to, is that counting starts at 0. So the letter that's at index 0 is the first letter, which is the character M. There actually is a reason for this madness, but you'll come across that later on. So that means that if we look at R1, we get the second character, because counting starts at 0, which is the E. Now we aren't limited to positive numbers. I can use a negative index. So R with -1 actually is the last character, which is a K. So I can refer to some character. Let's take the character I, counting across 0, 1, 2, 3, 4. So R4 should get me the I if I want to count backwards. -1, 2, 3, 4, 5. R -5 should indicate the same character. So whether I count from the beginning or count from the end, I can get the same character. Now we talk about a string as being immutable, a concept that we'll talk about a lot more as we go along. One way to think about that is that I can't put an index on the left-hand side of an assignment. So if I wanted to say R2 is X, saying that I'm going to take character at index 2 and change it to X, that won't be allowed, and we'll get a nasty message that says string objects don't support item assignment, which is another way of saying it's immutable. That means we can't change it. We can always make a new string that's a modification of an existing string, but we can't change a string in place. Now we aren't limited to indexing individual characters. We can actually refer to substrings, and in Python we call that slicing. So I can take something like, let's look at the slice that goes from 3 to 6. Now what you have to watch out for is this is what you probably learned in math as a half-open interval. So 3 to 6 is the character at index 3 up to, but not including, the one at 6. So we start with the third character, which is we start with the character at index 3, 0, 1, 2, 3. It's actually the fourth character. That's an R. And then we go up to, but not including, the character at index 6. That's an A, so we stop before that, so we get RIM. If I should leave a character out, if I should leave an index out, so if I did 5 colon, that means we start at the character whose index is 5 and go all the way to the end. And if I leave the first one out, then it's assumed that we start at the beginning. And I can also leave both of them out, which is the whole string. We can also talk about, or we can also use negative indices. So we can start at the character at index -4 and go to the end. That works. Now if we start in the reverse order, like start with the last character and go to some earlier character, then there really isn't a substring, so that's an empty one. If I want to work backwards, I can do something like start at character 2 from the end and go to the character 5 from the end and go backwards. So that would be a slice taking us from the second character from the end to the fifth character from the end up to but not including, of course, and the -1 tells us that we're working backwards. Now, a few times we get things in Python that we refer to as idioms. There are special expressions that really get their meaning, somewhat on how they're specified, but we also can take a special meaning out of it. So if I don't specify the beginning, the end, and only have the third item, the -1, that reverses the string. So that's an idiom to reverse a string, and there we see we have our Merrimack string backwards. And I'm not going to try and pronounce that. Final thing we'll take a quick look at here is comparison. Comparisons are done left to right and alphabetically, so I can say something like, is A less than B, which is saying does A come before B on the alphabet, and that's a Boolean expression, which is a value of true. It turns out that all capital letters are come before or are less than the lowercase letters, so you can get something like capital B is less than lowercase a because the uppercase come before the lowercase. We can compare strings like ABC and XYZ. So ABC comes before XYZ in the alphabet, so that's true. How about if we look at cake and cat? So which would come earlier alphabetically? Well, the way that Python does this, and it is as we would expect it to be, is we compare the first characters, they're the same. We compare the second characters, they're the same. We compare the third character, and we find that the K is less than the T, so that will now be a true expression. The fact that cake is longer than cat has no bearing on it. We start left to right, compare individual characters until we find characters that are different, and then we just do an alphabetical comparison on that. So there's a little bit of strings. They're a sequence of characters. So they're a collection that has a particular order. Therefore, we can refer to individual characters, which we call indexing. We can refer to collections of substrings of characters as we use that as slicing, and we use colons to indicate that. And then finally, we took a look at comparison. That's enough for now.